So, hello. I'm going to give you a tour of a language. So, PureScript, if in case you're not familiar with it at all, is a Haskell-like. It's a great start here. So it's Haskell-inspired. It's strictly evaluated. It's strongly typed, effectively typed, strict pure functional. And if you don't know what half of those things mean, then we're going to get into it over the course of the next 25 minutes. So, let's make a game. They're always fun. So this is where, can anyone in the back see that? Because this is going to get awkward otherwise. Cool. Yeah, okay. Well, we're going to see what I do about it. This is a module. This is PureScript at the top and JavaScript at the bottom. PureScript at the top is just defining a module, just like any other language like Haskell or Python or what have you. And it's got no dependencies and it's exporting no functions. And similar here, we've got JavaScript at the bottom, if you're familiar with CommonJS, no dependencies, exporting nothing. Cool. So when I say we're going to write a game, I kind of fibbed a little bit. What we're going to do is actually write something to make sure we know how the hell the language works first. So time-honored tradition, let's write a string reversal function. So we're going to define string reverse, and it takes a string and it returns a string. Single argument, single input, single argument. So string reverse x, we're just going to call the argument x, and we're just going to return it, because why the hell not? So that we've got a compiler that when we save it, we'll take this, check it as correct, and turn it into JavaScript, as you can see below. So you've got a very simple, in this case, we've just got the identity function basically, which is the function takes x, returns x, all very well and good. And at the moment, it's just exporting it all by default. So let's also use define another function using string reverse, which is just going to return a string. It takes no inputs at all, and is effectively a constant, because it can't do anything besides just return the same result over and over. It can't have any side effects, and so we're just going to use string reverse. Hello, and as you can see, we've just got effectively a constant sitting out of JavaScript. So let's go and fill this out. Now, if anyone, JavaScript people in the room here, how do you reverse a string? It's all sorts of wonderfully fun. So we're going to use the time-honored method of splitting by an empty string, and then taking the result of that, and then we're going to do a reverse on that to reverse the array, and then we're going to join it back together, join with an empty string. So, yeah, whatever. So that's generally how, that's a simple way of doing a JavaScript or whatever. And you've got the produce JavaScript. Now the call looks, the resulting JavaScript call here looks a little bit weird because of something called currying. I'm not really going to get into that beyond. It's just representing functions of multiple arguments in terms of single functions taking, functions taking single arguments. We'll get into it a little bit later. So the Haskell people in the room are probably screaming right now just because of this thing, mostly because we know about something called functional composition. This triple arrows thing is dot from Haskell, or triple arrow from category, I think. And it's just basically a way of building sort of a pipeline of functions. So same result here, code didn't even change. It knows how to handle a case of just sticking things together in a compositional pipeline. So that's all very well and good, but I think we should probably move on. And that will be enough of the generated JavaScript for the moment. Okay. So let's go and write the game itself. So we're going to define our own types here. We've got the game. Let's just say we're going to do rock, paper, scissors, paper, rock. So we've got define our hand in terms of hand is a type like string or integer. Instead of integer being all the potential numbers, or strings being all the potential strings. In here we've just got 3 potential things: rock, paper, scissors, and that's it. No nulls, no whatever. And also, let's just say a game result where we've just got the player 1, 1, or player 2, 1, or it was a draw. And let's just also define a function which takes 2 arguments, one, a hand, and a second hand, and returns a result. So let's just do the simplest thing that we'll possibly compile. And it's having a sad. Oh, sorry. Yep. Pardon me. Cool. And unfortunately, I can't make the REPL, the text size any bigger on the REPL, so I'm very sorry. So just a little bit of a aside, for Haskell's in the audience, there's no such thing as deriving show in PureScript. Deriving show may turn into deriving debug later or something. I haven't figured out how to do it. So in the meantime, in order to get the output on PSCI, what we've got is generics. We can derive generic, and then I'm just using the show instance. You can also derive the show instance directly if you like, just as the quickest way to getting PSCI. But hey, while we're at it, also deriving mechanisms. We've got a generic, EQ, and ORD, and that's it for the moment. Looking to extend that a little bit on. But anyway, so we're just using, we're just going to use the code we defined earlier. So winner rock and rock is going to be, cool. So rock and rock is going to be draw, and that's all very well and good. So let's fill this out with something called pattern matching, where you can say I'm expecting a particular input to be like a, for example, the first hand, where if we match on rock, and the second hand we match on rock, then the result is a draw, and that's pretty cool. And we've got, say, rock and paper equals the player 2-1, etc., etc., and you can go and fill out all the cases if you like. So what we've got here is we've got potential combinations here. We have 3 times 3, and if you haven't filled all those out, the compiler is going to give you, going to have a whinge here saying that you haven't filled out these potential combinations. So this, if you're familiar with Haskell, this looks familiar, but there's also something extra here. We can say that this function is partial. We intentionally don't accept all the inputs. We intentionally only capture, deal with 3 potential outputs, and it's on you if you use this. So when we say it's partial, the compiler leaves us alone, but anything using this needs to also define itself as partial all the way up the tree until some point you say, okay, I accept the responsibility, anything below me, I understand these are all partial, they may blow up at runtime, that's cool, I got this. And so that's a neat little feature that I really like in Haskell at some point, but we've got it here. But in this case, we're just being lazy. It's just because we haven't defined all the things. So I'm just going to go through and do that now. Yep. And then so rock and paper. Cool. All right, so let's actually get on with the game itself. But before we do that, let's have a look at some extra tools we've got with the language. I'm going to use, I'm sorry, this terminal is awfully finicky. I'm going to use something called YOW here, a package manager, to install both a test unit framework as well as something called quick check. And there's also something called strong check, which is basically small check and a few other things wrapped up, but it's basically some testing tools. And so I'm installing it with Bower because Bower is the package manager for PureScript. It's just a generic package manager we can use, and it's only used for PureScript dependencies, not anything in JavaScript. We'll come back to JavaScript in a tick. But so we've got a test, and for example, with here, I've just defined some assertions, as well as more complicated things like this property, which is a property is a way of saying, for example, for this, these particular random inputs, like give me a random hand and a random hand, and if they're the same, then it must be a draw, otherwise it's not a draw. Just little rules about things, as opposed to specifically listing all 9 combinations, you can sort of come up with some properties, and you can write winner in a way that's more amenable to coming up with these properties. But we're going to skip right on past this and get to the game itself. Sorry, my apologies. We're going to talk about FFI for the foreign function interface with JavaScript, as in calling JavaScript from PureScript. So back in our game, so we've got the game, the app.game module, but if we want to define anything in JavaScript, we can define a corresponding JavaScript file for that module. So we've got app.game, or in this case, we just got game.js, which is just simply a common, again, it's a common JS module, and you just export things that can then be consumed by the PureScript. So I'm going to use, first I'm just going to install, I'm just going to go install a library we'll know and love, leftpad, and I'm going to use that. Topical, yep. And then use that in our FFI. So we've got, much like any like Node.js, common.js file, you can require the dependencies and then go and use them in a function. And here we're exporting leftpad, which is a function left pad is a function of 3 arguments, so we represent in a curried fashion when we're defining FFI functions. It's a function that takes an argument, returning a function that you can give an argument to, returning a function, etc. And eventually, this is how you define things that are more amenable to PureScript. You can define things that are more JavaScript friendly in terms of saying this accepts 3 arguments and it only accepts 3 arguments in a row, but we're going to cover that in the workshop a little bit later. So, but on the PureScript side, we've got our FFI, which is just our FFI here, which is just saying left pad is a function that takes a string integer and a string and returns a string. Just trust me. So you define it in JavaScript. You say this is what the interface is in PureScript, and that's about as far as you go. The FFI is really lightweight, and so I'm just using that function just in regular PureScript below, just to to print out, say, a string padded hand, for example, in this case. So let's actually get on with the game itself. Jump the gun. So we have a very simple hello example. This is something called Pux. Pux is a UI framework for Facebook. It's PureScript. it's in no way baked into the language at all, and it's done in the style of Elm. And there's a couple of people in the audience I know who know Elm, so you're way ahead of everyone else right here. But so it's just something that defines things in terms of using a state to produce some HTML in a sort of a pure way, representing as a pure function. So for example, we have an initial state here. We're defining a type for our state, an initial state, and there's nothing going on here, and I'll explain this in a minute. And then what we're going to do is we're going to use that view state, using this in our view function, take that state and produce some HTML. So let's stop and explain what the hell's going on with this type, because that looks a little bit unfamiliar. It's a type alias, but we've got these sort of the brackets. Now that's something called a row type, and it's just, in this case, it's an object. It's just sugar for object, a data constructor, and then an argument, which is a set of row types. Now, an example row type here might be, for example, score. And a row type is a sort of a single slot where you can define a bunch of different labels to types. And so this could be score and foobar, and it could be a string. But in this case, we're just only interested in score itself. And so I'm just going to put that back in the sugar just for readability. But and then we've got the initial state, which is going to produce that state. So in order to do that, we're going to use the the record sugar to match that type. All really well and good so far. So in this Pux, this UI sort of flow, in order to change the state, to therefore change what is rendered, you have actions which indicate, basically sort of flags indicating what you want to do. For example, let's just say win is an action. And then we've got an update function that expects those and say, let's match on win and the state, and then let's update the state to update the score. So we're going to produce a new state. We've got the update function that when win comes through, it takes the state and takes the score from that state and adds or increments it and then tosses it back out. And that is then in turn fed to the view, which then produces markup. So one more thing we need to do here is get a button going. And this is just a way of writing HTML. It's just in terms of functions as opposed to markup or what have you. So a button takes an onClick, and we're going to take an event and completely ignore it and just say that when this is clicked, we want to trigger the win action. And then we're just going to have some text in there, which is just show me the current score. Sorry, it's scrolling a little bit to the right. Pass error. Oh yeah. Pass errors in real time. Fantastic. Give it a minute. Oh, come on. Oh, sorry, I was unhappy with something else. No, that's fine. That should be it. So I'm just going to jump directly to our result here. Oh, sorry, it's always the equal. It's the setter thing as opposed to, sorry, it was this little equal sign going on here. So anyway, so we've got something that when we click, we trigger it. We say we want the action. It'll goes through the update and then changes the state. We have a number of increments. It's amazing. So that's a simple pure example. We're gonna go and add reset game here, which is just going to be another action. So we've got an action, a win or reset game, and then therefore corresponding we have an update function. We can expect a win or a reset game, and it just does different things. So in this case, we've just got button and it resets. So we can just sort of expand this out. And this is just a small component in the larger sort of Pux application, but just keeping it simple here. Okay. So let's make this a little more exciting. Cool. So we've expanded the game out, and we've expanded out to multiple scores, and so some things representing the current round, and basically just adding a lot more smarts, a lot more UI, and a lot more handling of updates. But it gives us a little. This is not my best day ever. Okay, well, thank you for the timely pause. Moving right along. So, okay, this is a pure thing. This is entirely described in terms of that pure update. We've got an update, action, state to state. Now, this is all pure. It can't interact with the outside world. There's no randomness involved. So, in order to do that, and we've got the AI, which is literally, rock, always been a rock. And so what we want to do is introduce something that's actually that interact with the random number generator, for example. So what we've got here is we're going to use the EFF type. EFF is like IO in Haskell. And EFF takes as an argument a row type, which indicates the kind of effects it can have. So we've got that label to type thing going on, except we've got a different type going on. We've got sort of an effect type. But you think about the same thing. Instead of a string, we've got random. It indicates a randomness effect. And so we have this much the same way we had before. We've got the row and the potential things, but it's also got an extra parameter saying that not only does this function this function requires randomness, but it can have other stuff going on as well. It's something called an open row, where you can have not only this, for example, the earlier example with state, you only want something that has score and nothing else. You don't care about any things that may happen to match that. But in this example, we've got an open row where we've got these, we want randomness, but also there can be other stuff going on. Like we can interact with the DOM, we can interact with the console, we can have the AJAX effect going on. And so it allows us to compose these effectful functions together. So I'm just going to hand wave over integrating that here. So I've correspondingly have updated the it's what in the hell? Sorry, I'm sorry, it's just reset to. Okay. Sorry, I haven't hit this before. I've got a bunch of exit hatches specifically so this doesn't happen, but apparently not. Okay, and now it's perfectly happy with it. My apologies. Okay, well, frankly that sucks a little bit, but I'm just going to keep going regardless with the code example. And yeah, sorry. Okay, well, so we've got come up with a random AI. The AI is effectful and uses this random type, and in doing so, we need to change how the update functions work. We need to have this effectful update so that updates when they take an action and a state producing an effectful action. So you can muck around with the state, but also have side effects going on as well. And so in this case, what we're doing was just integrating an AI which is using a random number generator and a couple of other rules, but it's integrating this into the set of effects here. And so if we could see the example, we've added stuff like previous play history, and we also have FFI working with the audio context. And I think, unfortunately, I'm going to have to wrap it up there because there's very little I can do without the live demo going on. But I'm just going to talk about briefly just further resources you can have a look at. I'm very sorry about this, folks. So we've got the PureScript site itself, which has a bunch of articles which detail how to use, for example, FFI, so how to interact with JavaScript, or alternatively how to consume PureScript from JavaScript, as well as a bunch of basic bits of language deriving or what have you. So a bunch of little articles, but there's also the PureScript book, where it's free to read online, profits, charity, etc. And so that steps through the language piece by piece with examples, and it comes with a library examples to try out as well. But if you're new to Haskell at all, I would really recommend the Haskell book, which is basically starts at nothing and works gradually upwards to give you something. The PureScript book unfortunately makes a few jumps in terms of what it thinks you already know about Haskell, but the Haskell book will basically starts at lambda calculus. It sounds intimidating, but it just starts at absolutely nothing and then works all the way up from there. So there's a workshop on at 1 p.m., which I swear is not going to break as badly as that did. I'm very sorry. But I've got the talk stuff up online, as well as the workshop materials. I'll see any of you if you're interested at 1 p.m. And just regards to the workshop, if you want to attend and you want to get your stuff preloaded, like I've got a VM or some other bits you can pull off a USB key, come see me and I'll give you the USB key to just start copying stuff. I'll just go and jump direct to the questions at this point.